All right, I've got two examples for us today to kind of refresh on talking about systems last week and look at a couple of word problems. So we're looking at more of an application here. So remember that it's been a couple of days, but we talked about our two methods for solving a system of equations. We can use substitution or we can use elimination. So if you were not here on those days, make sure you go back and get those notes before you complete this part, okay? So anytime you're solving an applied problem where you're looking at a word problem or something like that, these steps are always going to be a good reference point. So step one is obviously to read the problem carefully. Make sure you understand what is given and what is to be found. What is the question and what is the unknown, okay? Step two is to define your variables. That is really, really important and should always be written down. If you're going to use A and B, you have to tell me what they are. If you're going to use X and Y, you have to tell me what they are, especially because it's going to matter which one is which. So you always need to make sure that you define your variables and that you write it down, okay? You're going to create a system of equations that relates the two unknowns. Now, you're usually going to be given two different, I would call them constraints in your problem. So some really common ones would be like the total number of something versus the total amount of something. So for example, the total number of coins that are in a jar along with the total value of the coins in the jar, or the total number of tickets sold versus the total amount of money that you got for the tickets. So each of those are going to be related to the number of tickets, but it's going to be two different equations. So once you have your equations, you're going to solve. Make sure you answer the problem. Sometimes it's going to ask you for one of the variables. Sometimes it's going to ask you for both. Pay attention to units and those sorts of things. So let's go ahead and look at these two examples really quickly. And here's sort of a visual outline of what we need to be looking for. So number 7 says, to raise money for new football uniforms, your school sells silkscreen t-shirts. Short sleeve t-shirts cost the school $5 each and are sold for $8 each. Long sleeve t-shirts cost the school $7 each and are sold for $12 each. The school spends a total of $2,500 on t-shirts and sells all of them for $4,200. How many of the short sleeve t-shirts are sold? Now, the question is always the best place to look. It's usually at the end. It's the best place to look for what your variables should be. And the question is how many. So what we don't know in this problem is the number of t-shirts that are sold. And we have two different kinds, short sleeve and long sleeve. So I'm going to let X equal, I'm not just going to say short sleeve, because there's lots of things I could count about the short sleeve, their cost, their size, their weight of each package or something like that. So we need to be specific that X is standing for the number of short sleeved. And then I'm going to let Y equal the number of long sleeve. Okay. So we have two different equations because they gave us like two different totals here. We know that there is a total for the amount that they spent and a total for the amount that they sell. And so we can use that information. They told us that short sleeve t-shirts cost $5 each. So the total cost of short sleeve t-shirts is going to be 5 times however many t-shirts you bought. If they each cost $5 and I bought 10, then I spent $50, 5 times 10. Plus, same thing, short sleeve shirts cost the school $7. And then the total amount that the school spent was $2,500. You're going to write a similar equation for the amount of money that they make. So they sell each short sleeve shirt for $8. So that's going to be $8 times the number of short sleeved. And they sell long sleeve shirts for $12. So that's $12 times the number of long sleeved. And they told us that the total we make from selling them is $4,200. Okay, so now we're going to solve that system of equations. We can use either method we want here, but I would say that neither one of these variables would be quick and easy to solve for in order to use substitution. So I'm going to go ahead and use elimination. In order to do that, I just need to pick a variable that I'm going to eliminate. So I'm going to eliminate the x's here because those numbers are smaller. Since one of them needs to be negative, it doesn't matter which, but we do need to multiply by a negative on one of them. I'm going to multiply the top by -8 and the bottom by +5. I'm basically just switching these two coefficients. And so I'm going to distribute. So I get -40x minus 56y equals, oh gosh, I don't have my calculator next to me. Here it is. Okay. So we have 2,500 times 8, which is 20,000. Oops, negative. And then when we multiply by 5, we get positive 40x plus 60y equals 4,200 times 5, which is 21,000. Now that we've created opposites with our x's, we're always going to add our equations straight down. So those make 0. We get 4y equals positive 1,000. Remember that 20,000 there was negative. And then divide by 4 on both sides, and we should get 250. So 250 is our y value, and y was the number of long sleeve shirts. So again, let's check the question. We want the number of short sleeve, okay? We just found the number of long sleeved, and so we want to plug that back in to be able to solve. So I'm going to take this now and plug it into either equation. I'm going to do the top. So I get 5x plus 7 times 250 equals 2,500. 7 times 250, it's too early in the morning for me to try to do some mental math here, is going to be 1,750. So we subtract from both sides and we get 5x equals 750. And when we do 750 divided by 5, we get 150 for x. Now the question was not solve an equation for x and y. The question was how many short sleeve shirts. So we need to make sure we answer the question. 150 short sleeved. And that is our solution. Okay. Let's look at one more. It says Jennifer is making a quilt that has alternating stripes of regular quilting fabric and satin fabric. She spends $76 total on 16 yards of the two fabrics at a fabric store. Satin fabric costs $6 per yard and quilting fabric costs $4 per yard. How much of each type of fabric did she buy? Excuse me. Now again, take a second to look at the word problem and see if you can define what your variables are going to be. It is always the best place to look is at the question to kind of see what quantity it is that you are finding. So take a second, see if you can define your variables. So since our question is asking how much, that's what we should be finding. How much or how many yards of the regular fabric and how many yards of the satin fabric, okay? So that's what we need to define. So I'm going to let x equal the number of yards of quilting. I'm going to let y equal the number of yards of satin. So the amount of the two types of fabrics is what we are looking for here. Now they told us two different things about it. They told us that she spends $76 total. So that's the total cost. And they told us that she uses a total of 16 yards. So we have a rule for the cost of all of the fabric, and we have a rule for the amount of all of the fabric. Now, when we do cost, because our variables stand for number, we're going to have to multiply it by cost. So it tells us that satin fabric costs $6 per yard and quilting fabric costs $4 per yard. So since my X is quilting, that's going to be 4X. That tells me the cost for all of my quilting fabric, plus 6Y, that's the cost for all of my satin. And combined, she spent a total of $76. Then it tells us that the total amount that she bought was 16 yards. So that one is just going to be simply the number of yards of quilting plus the number of yards of satin equals the total of 16. Okay, so again, our first equation was based on the total amount that it cost, and the second equation is based on the total number of yards. Okay, so we are trying to find each type and how much she got of each. And then we can choose a method here. Now, this one would be a really good candidate for substitution or for elimination. It doesn't make any difference which one you use. I'm going to use substitution this time just to review something a little bit different. Okay, so if I'm going to use substitution, that means I need to get one of these variables by itself. I'm going to subtract x from both sides, and that gives me that y is equal to 16 minus x. So now I'm going to come to the original equation and take out the y. So I have 4x plus 6 times 16 minus x instead of y equals 76. And that's what we're going to solve. So 4x plus 96 minus 6x equals 76. When I combine like terms here, I'm going to get negative 2x. And if I subtract 96 from both sides, I get negative 20. So we get that x is equal to 10. And since I needed each type, I do need to solve for y. So I'm going to plug it into that green equation. 16 minus 10 equals 6. And so now to answer the question, we know that we have 10 yards of the quilting fabric. And we have 6 yards of the satin fabric. Okay? These are all kind of different, but just make sure that you take the time to get your variables based on the question. Defining your variables is really going to help you know how to set up the equation. You're looking for 2 different rules being given, and then you can solve it using any method you want. So your task for today is to go ahead and finish up worksheet 1 now that we have finished up these notes, and I will see you later.